Welcome back to Examplan's course on IGCSE Physics. In this video, we'll be looking at plotting and interpreting velocity time graphs. When you plot a velocity time graph, you must make sure that the velocity is on the y-axis and time is on the x-axis, and always remember to include the units. As we have seen before, interpreting a graph means you should be able to 1. Describe the motion the graph represents, 2. Being able to read values off the graph, and 3. Calculate the gradient. When describing the motion of the graph, you must look at the gradient. For a gradient, the velocity time graph is acceleration. Be very careful here not to confuse this with the distance time graph. For a distance time graph, the gradient represents speed, not acceleration. So, always double check the axes before you begin. Let's look at an example. A constant gradient means the object is accelerating constantly. If the gradient is positive, it means the car is speeding up. A larger positive gradient means the car is speeding up quicker, the gradient is larger, and therefore the acceleration is larger. A flat line, or zero gradient, means the acceleration is zero, and therefore the car must be travelling at constant speed. In this case, we can see the constant speed is 30 meters per second. A negative gradient means the car is slowing down, and you can see that the speed is decreasing. So to recap, positive gradient means it's speeding up, a negative gradient means it's slowing down, flat gradient or zero gradient means the car is travelling at constant speed. Reading values. To find the velocity of an object at a given time, start with the time, go up and across to find the velocity. In this example, at 2 seconds, the object is going at 30 meters per second. To find the time for a particular velocity, you need to do the opposite. Start with that velocity, go across and down to find the time. For example, there are 2 times when the car is going at 10 meters per second. These are 1 second and 6 seconds. Exam technique. Like with any graph that tells a story, it is best to split the graph into sections based on the independent variable, and then describe each section in turn. In this case, we need to explain how we know the motion of an object by describing the gradient, and also quote values from the graph. Between 1 and 1.5 seconds, the car is accelerating, but at a decreasing rate. This is because the gradient is positive, but the gradient is also getting smaller. Between 1.5 and 4 seconds, the car is going at a constant speed, because the gradient is 0 and so the acceleration is 0. The constant speed is 25 meters per second. Between 4 and 6 seconds, the car is decelerating at a constant rate. We know this because the gradient is negative, telling us it is decelerating, and constant, telling us it's a constant acceleration. Between 6 and 6.5 seconds, the car is also decelerating, but at a greater rate because the gradient is more negative. Gradient. You need to be able to calculate the acceleration from a velocity time graph. We already know that acceleration is the gradient of the graph. So, to calculate the acceleration, we can calculate the gradient. To find the gradient, we do the change in y, in this case velocity, divided by the change in x, in this case time. In this example, the change in y is 20 meters per second, and the change in x is 5 seconds. Gradient therefore equals 20 meters per second divided by 5 seconds, giving us an acceleration of 4 meters per second squared. That's it for this video. Move on to the next video to see a practice exam question.